Hey, what's going on, all y'all? I'm back with another STAAR release test question to look at with you. This one has to do with dilating by a scale factor. Again, this time we're going to dilate an object that has volume. Okay, now remember volume, length times width times height. Okay, 3 dimensions: length times width times height. Okay, 3 dimensions. So volume is going to be in cubic units. Okay, cubic units of volume. Alright, right now we're going to look at a sphere dilated by a scale factor of 1.04. So if you were to draw a diagram, you would have your sphere, and you're going to dilate it by a scale factor of 1.04, which is bigger than 1. So we know that this is an enlargement. We're going to make a bigger sphere. Okay? Alright, now, a sphere doesn't just have a length, right? And it doesn't just have a width. It's also got a depth. So it's got 3 dimensions. Okay? And each one of those is going to be dilated by a scale factor of k. So it's going to be scale factor times scale factor times scale factor to come up with scale factor squared or cubed. So there's only there's only one of these answers that makes sense. The volume of the new sphere is 1.04 times. No, that'd just be length. Say we had a length right here. If I measured this, multiplied it by 1.04, I'd get length times scale factor. Now imagine that I had an area here, and I was going to dilate it by scale factor 1.04, which is an enlargement. That means this side would be multiplied by 1.04 to come up with this side, and this side to come up with that side. So its area would be scale factor times scale factor bigger, which would be scale factor to the second power. Okay? This one has 3 dimensions: scale factor times scale factor times scale factor. So it's going to be to the third power. To the third power. Alright, so this is going to be your answer right there. To the third power. Alright, so let's take a look at a simpler problem. And let's say that we have a cube, and we're going to dilate that cube by a scale factor of, let's say, 3. Okay? Alright, so the scale factor is going to be 3. Alright? Let's say that it's 2 units on a side for this cube. 2 times 2 times 2. Alright, so the original volume is equal to 2 times 2 times 2. Alright, 2 times 2 is 4, times 2 is 8. It's going to be 8. Let's say that's inches cubed. Now let's figure out this bigger one. The scale factor is going to be 3 each time. So this one's going to be 6. 2 times 3 is 6. 6 and 6. So its new volume is 6 times 6 times 6, which is 36 times 6. 36 times 6. 6 times 30 is 180 plus 36, 216, I think. 18, 21, 216. 216 inches cubed. Okay. Alright. Okay, so let's take a look. K is 3. So let's see if this holds up. Scale factor times scale factor times scale factor. Okay. So let's see how their volumes are related. 8 to 216 should be scale factor of volume of 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay? Their volumes should be related by a scale factor of 27. So I'll do 216 divided by 8. 8 into 21 is 3 is 24, so it's going to be 2. 16. It's 5. Carry the 6. 8 times 7 is 56. 27 is the scale factor. Okay, that's all there is to it. Answer choice B. Volume is 1.04 to the third times the volume of the original sphere. Okay. If it was area, it would be the second power. This makes no sense because you never want to touch the scale factor. And this would just be a simple length. Alright, that's all there is to it.